Bismillahirrahmanirrahim. Hello, dear students. I hope you have a good evening and everything is as you wish. These days, the best wish is health, with this condition of COVID disease. So I hope you are all in good health. Well, we finished chapter 1 last session, and now I will upload the second session. So we should wait some time to see how long does it take to upload chapter 2. Are you all well? Are you all well? So what is the situation of condition of COVID in Iraq? I hope you have not lost any of your relatives and families and friends. It's a very, very bad disease, and who knows what happens in the future. Well, chapter 2 is uploaded now. No, I cannot, because I must complete this chapter. I have to make some changes to the PDF file, and while I am teaching you, I can make changes. So once I finish chapter 2, I will upload it on Darsa website. Okay. You didn't answer my question. I asked you about condition of COVID-19 in Iraq. Are you all in well? You and your relatives and family? Have you had a chance to be vaccinated against COVID-19, coronavirus? Have you all been vaccinated? I don't know about the condition of COVID in Iraq. Is it available for all people in Iraq? COVID vaccine? So I suppose you all have been vaccinated. Yes? Which vaccination do you have in Iraq? Sputnik, I don't know, Pfizer, Moderna, or Sinopharm? Which one? Which one is available for you in Iraq? Pfizer, okay. Is it free? Is it free in Iraq for all people? Good. Pfizer and Sinopharm. Good. Have you been vaccinated for the first dose or the second dose? Very good. Okay. So, in the previous chapter, chapter 1, we discussed about some fundamental and basic information about distributed systems. We begin distributed systems with definition, and then I gave you some examples of distributed systems. Also, we discussed some problems and some different types of distributed systems. We compared distributed systems with parallel computing, and also we talked about some types of distributed systems, such as pervasive distributed systems, information distributed systems, and transaction distributed systems. Okay, so I assume that now you have enough and sufficient information about basics in distributed systems. In this chapter, chapter 2, we will study architectures of distributed systems. Well, please wait a moment. I must answer an SMS now. So I'm sorry, please wait wait a minute. Well, as I told you, in this chapter we will study architectures of distributed systems. Okay. Distributed systems are consist of some different software components. I mean, there are many different software components that are distributed between machines in distributed systems. So, to solve this complexity and to manage this complexity, it is very important that these systems are properly organized. We want to organize these systems to manage the complexity of distributed software components. There are several ways to view the organization of distributed systems, but it is clear enough to distinguish between logically organizing a set of software components and, on the other hand, real physical realization. So, software architecture is a way that we logically organize software components. We have different software components in distributed system, and software architecture helps us to logically organize these software components. On the other hand, we must find a way to place those software components on real machines. It is system architecture. That's it. Is it clear? Good, very good, very good. So, I repeat again, we have different software components in distributed systems. It is complex. To manage this complexity, we need to find and to organize logically these software components. It is software architecture. And also, we need to implement those software components on real machines. How we can do it? It is about system architecture. As you can see, system architecture, the actual realization of a distributed system which instantiate and place software components on real machines. It's physically, not logically. But software architectures talks about logically organization. So, we begin our discussion of architecture by examining the logical organizations of systems. So, we are talking now, firstly, we are talking about logical organizations of software components here. Important styles of architecture for distributed systems logically. Architecture for distributed systems are these four styles: layered architectures, object-based architectures, data-centered architectures, and event-based architectures. The concept of architectural style is very important. These methods include the components and how the components are connected to each other, and the exchange of data between the components, and finally how to integrate these factors to form a single system. It is logical organizational software components. I repeat it again, it's important. The concept of architectural style is very, very important. Such a method includes the components and how the components are connected to each other. Okay, we have some software components, and this architecture must tell us how the components are connected to each other, how, and also about the exchange of data between the components. So these styles can say about exchange of data between the components, how data is exchanged between the components, and also how to integrate these factors to form a single system. So as I told you, in general, there are 4 styles of architecture of distributed systems: layered, object-based, data-centered, and event-based. Got it? Very good. So, the first style is layered architectures. It has a very simple idea behind. Very simple idea. Components are organized in a layered format. We have different layers, and components are organized in layered format. Each component in a layer can do a down call. It means each layer can request from the bottom layer, and also the result can go up to the top layer. For example, layer 3 can request from layer 2, request something. For example, request to receive some data, or request to do a calculation or process. Layer 3 can request from layer 2, and the result from layer 2 goes up to the layer 3. Requests go down and results go up. That's it. A very simple idea. It's a logical organization of software components. We put software components in different layers, and we apply this rule. Requests go down and results go up. That's it. Clear? Picture A shows this style. Okay, layered style, the left picture, picture A. Layered style is used for client-server systems. I think you have heard about it, client-server systems. We will talk about it in detail later, okay? Right picture, picture B, shows the second style, object-based architecture style, or it is called service-oriented architecture sometimes. This architectural style is based on an arrangement of loosely coupled objects. So it is less structured. Each object corresponds to what we define as a software component. So software components is exactly objects here. How these software components can communicate between each other? With RPC, remote procedure call, or RMI, remote method invocation. Some popular example of such architectural style is Java RMI, or web services, or REST API calls, if you heard it. REST API, web services, Java RMI. These are some examples of object-based architecture. That's it. Very, very simple. The third style is about resource-based architectures, or data-centered. Data-centered. Let me go back to this slide. Here, we studied layered architectures. We talked about object-based architectures, and the next style is data-centered architecture. Data-centered or resource-based architectures. One problem with service composition is that connecting multiple components can easily lead to an integration nightmare. Integration problem. We could have integration problems. However, in resource-based architecture or data-centered architecture, we have a single data repository. A single data repository. So all the processes or all the software components can communicate and use these shared data repository. It's a very simple style too. Some applications that use distributed file systems are a good example of such architectural style. For example, if you have heard about GFS or Google File System, it's a distributed file system, and it's based on this style. Also, some distributed systems based on web. Some distributed systems based on web, they are also implemented in this style, data-centered architecture style. That's it. And the last one, the last style is about event-based style. Event-based style. It is based on event. The name implies that this style is based on event. It is also called publish-subscribe. Publish-subscribe style. If you look at the left picture, picture A, In this style, we have different software components, and each software component can publish events. Okay. For example, suppose component 1 wants to make a communication with component 3. Component 1 publishes some events, and we expect that component 3 receives these events. Component 3 is subscribed for this event, so it can receive it. But for example, component 2 is not subscribed in this event, in this specific event, so it cannot see it. It cannot receive it. That is why we call this style as publish subscribe. Components publish some events, and we can be sure that only those components that are subscribed in this event can receive it. It's the main idea in event-based style. Clear? If it's not clear, please tell me so I can give you some more explanation. Repeat. Okay. Okay, I understand. Okay. So let me go back. I start from the beginning of this chapter. Okay. I quickly repeat. Please pay attention. In this chapter, we want to study architectures of distributed systems. In general, we can say that there are two categories for architecture of distributed systems. In the first view, we want to organize software components logically. It is software architecture. I told you we have different software components in distributed systems. Software components can be applications, can be some procedures, can be some processes. You know, these are software components in distributed systems. Okay, so how to logically organize these software components? We study it in software architecture. And the next view is about physically organization. How to place software components on real machines. It's about system architecture. Good? Okay. Can I go to the next slide? Okay. So, firstly, we want to talk about software architecture. Software architecture. The first topic is software architecture. Okay. We have different styles of software architecture. We want to logically organize software components. We have four main styles. The first style is layered architectures. The second, object-based architectures. The third, data-centered architectures. And lastly, event-based architectures. Firstly, layered architectures. Look at picture A, left picture. We organize software components as different layers, okay, from layer N to layer 1. The top layer, for example, layer 3. Layer 3 can send a request to layer 2 and can only receive the result from layer 2. Okay, it's a rule in layered style. That's it. So in this style, components can make communication between each other. If layer N or if layer 5 wants to receive some results from layer 3, firstly must send a request to layer 4. Layer 5 send a request to layer 4, and then layer 4 send a request to layer 3. The layer 3 provides a result, and the result is go up to layer 4 and then from layer 4 to layer 5. It's a rule in layered style. And in this style, components can make communication. Yes, layer 3 can send a request to layer 2 and at the same time can provide a result and send the result to layer 4. Okay? Layer 3 can send a request to layer 2, the bottom layer, and send a result to layer 4, the up layer. Okay, it's the first style. The second style is about object-based style. In this style, we assume objects as software components or software components as objects. So objects or software components can communicate between each other by using RPC, remote procedure call. We talked about remote procedure call in previous sessions. Or with RMI, remote method invocation. That's it. The third style is data-centered style. Data-centered style is a style that we use a data repository, a shared and a single data repository, and all the software components can communicate with this repository. Client-server style or client-server model is based on this style, data-centered or resource-based architecture. That's it. So I spoke about the first three styles, and the last style, the fourth style, is event-based style. Look at the left picture again, picture A here. We have different software components. Software components in this style can publish events, and they can be sure that only those components that are subscribed in this event can receive it. Other components cannot receive this event. So it is a solution, it is a way to make communication between software components. This style is called event-based. It is publish-subscribe style. Components publish events For example, component 1 wants to make a communication with component 4. Okay, component 1 publishes an event, and only those components that are subscribed in this event can receive it. For example, in this example, component 4 is subscribed in this event, so it can receive it, but component 3 cannot receive it. That is why we say publish subscribe. انتشار عضویت. انتشار عضویت. Publish subscribe. Clear? Yes? Okay. Good. Well, I talked about 4 main styles, software architectures styles. Okay, I talked about it. But we can have a hybrid style too. In this hybrid style, we combine the style number 3 with style number 4, data-centered style and event-based style. Okay. So if we use these 2 styles and combine them, we can have shared database style. Right picture, picture B. Look at this picture. In this style, like data-centered style, we have a shared data space. Okay, we have a shared data space like data-centered style, and also we have publish subscribe mechanism like event-based style. So it is a hybrid style, a hybrid of event-based and data-centered style. It is called shared database. That's it. Clear? Please give me some feedbacks. I want to be sure that you completely understand the lesson. Okay, very good. All I said was about software architecture. There is nothing to add. There is nothing to add for software architectures. Now we can go to system architecture styles. System architecture. Let me go back to this style again, this slide again. Here we talked about software architectures and different styles of software architectures, and also now we want to talk about system architecture. System architecture talks about physically organization of components, not logically. Physically organization. Why it's hybrid? I tell you, okay. In system architecture, we discuss about how to physically organize components. If you pay attention, in these 4 styles, we talked about how to logically organize components, like layered style. Look at the left picture, it's layered style. Look at the right picture, it's object-based style. It's logically organization of software components and find a way to communicate software components between each other. But it's not physically, it's logically. We talked about these two, layered based and object based. Also, I said about data-centered style, and I said that we can have a data repository and components can communicate with this data repository. It is data-centered, like client-server model. And also event-based is about some publish and subscribe mechanisms. Components publishes events, and those components that are subscribed in this event can receive it. It is event-based. We can combine the third style with the fourth style, data-centered style and event-based style. So it is hybrid of data-centered style and event-based style. Why it is hybrid? Because in this style, look at the right picture, picture B. In this style, we have a shared data space, like data-centered style. We had a shared data repository, okay? So it is similar to data-centered style. Also, we have publish subscribe mechanisms like event-based style. So it is similar to event-based style too. That is why we say it is a hybrid of these two styles. It is called shared database. That's it. Got it, Muhammad Jafar? Is this chapter easy or hard for you? Is this chapter, chapter 2, easy or hard for you? Is it easy to understand? Medium. Wow, خیلی سخت. So. Okay, if you have difficulty with understanding this chapter, I strongly recommend you to use your book. After I finish teaching, please go and open your book and read this chapter on your book, chapter 2. It can help you to better understand. So, software architectures finished. Now we want to go to system architectures. It's physically organization of software components on distributed systems. That's it. How to physically organize software components in distributed systems on real machines. Generally, we have three main architectures, system architectures: centralized architectures, decentralized architecture, and hybrid architecture. Hybrid of these two, centralized and decentralized. So, physical organization of components could be centralized, could be decentralized, or a hybrid of these two. Yes, hybrid, centralized and decentralized. Hybrid. Hybrid means مرکب. مرکب. Okay? ترکیب. مرکب. Mix. Yes, exactly. Mix. It means in hybrid architecture, we have some similarities with centralized architecture and we have some similarities with decentralized architecture. That is why we say it's hybrid architecture. That's it. Hybrid means tarkib. When we make tarkib between these two architectures, we can have a hybrid architecture. Okay. But centralized architecture, what is centralized architecture in system architectures, in distributed systems? We are talking about physical organization of components. It is called system architectures. I said that there are three main system architectures: centralized, decentralized, and hybrid. The first one is centralized architecture. I want to start to talk about centralized architecture with an example. It's basic client-server model. Look at this picture. At first, you must know that there are some processes offering services, provide services. They are called servers. So server provides service. For whom? For clients. So we have some clients that clients use services. Servers provide services and client use the services that servers provided. Look at this picture. Suppose that a client means some computers, some processes that wants a service, want to use a service or services. Client send a request to server. Let me show you. We are here. Client sends a request to a server. The server receives the request. It takes some time to process and provide the service here. It takes some time that server can provide service. And then when the service is provided, the server sends the reply to the client here. The client is waiting to receive the reply, and here the client can receive the reply and can use the service. It's a very, very simple and basic model called request reply. Request reply. Client send request, servers provide services and sends reply. That's it. Is it clear for you? For all the students, other students, is it clear? Okay. I see that only 3 or 4 students answer me and send me feedback. How about other students? We have 27 students in this class. Okay, yes, very good. This simple request reply model can work in local area networks. Why? Because in local area networks, the network is reliable. But when we are in wide area network, WAN, like internet, it's not good, it's not efficient. it doesn't work properly. We may have some problems with this model. Let me give you an example. Consider you want to transfer money between your accounts. You are using online banking, okay? You are client. Your computer is client, and the server of the bank is server. You send a request here. You are client. You send a request to the server to transfer money. Okay. For example, suppose you are going to buy something, and you use your credit card to pay the money. Okay. The POS device in the shop, in the store, is client, and the server of the bank is server. Okay. When you use your MasterCard or your credit card to pay the money, you put the money, you put your password, and you press OK button. And this time, the client send a request to server. The server here, the server receives your request. Okay, so here the service is provided for you. What is the service here? Buying, paying money. Okay, so the operation is successfully done, and then here the server sends a reply to the client, sends the response to the client. But unfortunately, at this time, exactly at this time, the message is lost. The reply message of the server is lost. Why? Because the network is unreliable. We have some noises in our network, and the message may be lost. Okay, so what happens? Client is still waiting for the result, but the client cannot receive anything. The operation is done successfully, but client cannot receive anything. So the client doesn't know that the operation is done successfully. So what happens? One solution is that we use a timer in client. So client cannot wait forever. It waits for example, 1 minute at most. It's about the timer, okay? When the timer finishes, then the client can assume that its request is lost. The client thinks that the request is lost, the request here. So the client repeats to send a request again. Repeats to send a request again. To repeat sending the request. The server again receives the request. The server successfully received this request. So this is the second request that the server receives. Again, a process is being done in server. The operation is done successfully in server again. So it is the second time that this process is done on server. It's not good because you want to buy something one time, not 2 times. And again, server sends the reply, and this time client receives the reply, and client can be sure that the operation is done successfully. But the client does not know that the operation was done 2 times. It's the problem. It's the problem in some networks that are unreliable. Was it clear for you? Mr. Mustafa, if it's clear for you, can you translate and explain it in Arabic for your friends? Yes, we talked about this situation in failure transparency too. It's about failure transparency too, yeah. Who can explain this example in Arabic? Mr. Ziauddin, I enabled your microphone. You can start.
Salam, doctor. I don't know if my voice is clear. Hello?
Could you speak with a hard sound? I can't hear you correctly here.
Now it's okay, doctor?
Your voice is not. Yeah, it's clear
I
now.
increased the volume.
I can hear you. Okay. Can you
Yes,
explain this example in
السلام عليكم
Arabic?
أساتذة. الأستاذ هنا دا يتكلم
Okay.
على هذا المثال اللي هو Basic Client Server Model. هذا الموديل عبارة عن يقول لك اكو كلاينت واكو سيرفر. الكلاينت اللي هو مثل ما يقول احنا او اي شخص يريد مثل ما يقول يستخدم فد خدمة معينة، مثل ما هسه اعطى مثال انه حساب مصرفي تريد تستلم فلوس مثلا من مصرف. فانت اول شيء تفتح الحاسبة تدز طلب للمصرف باعتبار انت كلاينت، تدز الطلب مالتك اللي هو ريكوست، تدزه للسيرفر اللي هو البنك. اوكي، البنك شو راح يسوي؟ راح يوصل له الطلب مالتك، راح يعالجه، راح يشوف شنو اللي تريد انت، مثلا على سبيل المثال تحويل فلوس. على ما يعالج الطلب مالتك وراها راح يرد لك ريبلاي. اوكي، يعني اما يتم التحويل او مرات ما يتم التحويل. ليش يصير تاخير مثلا او فشل يصير؟ زين، من يصير فشل الكلاينت خو ما يظل ينتظر الريكوست، ينتظر مثلا ايش قد يظل ينتظر حتى يستلمه. فايش سووا بهاي الحاله؟ حطوا تايمر. هذا التايمر ايش قد؟ على سبيل المثال دقيقه واحده. فالكلاينت من يدز الريكوست مالته للسيرفر اللي هو البنك على ما يعالج الطلب مال الكلاينت اللي هو ريكوست، وراه يدز شو اسمه الجواب او الريبلاي للكلاينت خلال دقيقه. اذا الكلاينت استلم الريبلاي الجواب مثل ما تقول مال الطلب، هاي كان بها اوكي. اذا ما استلمه خلال دقيقه شو راح يسوي؟ راح لازم يدزه مره ثانيه. الكلاينت يدز طلب ثاني للسيرفر حتى يعالج، وهمات يدز له ريبلاي. بهاي الحاله اذا استلمه اوكي، هاي تمت العمليه بنجاح. اذا ما استلم معناها همت اكو خطا ولازم يعيد الارسال مره ثانيه. Doctor, I finished the explanation for this example, but I don't know if all the students they hear my voice or not.
Thank you, Ziauddin. Very good.
Welcome, doctor. Welcome, doctor.
So I suppose it's clear now for all the students. And how can we solve this problem? How can we solve this problem? There are many different solutions. One solution is using idempotent messages or idempotent requests. Idempotent request means some request that must be done only one time. We are not allowed to repeat to process these messages. So if the server receives an idempotent request, the server knows that this request must be processed only one time. If it is done successfully and the client again repeated this request, the server do not process it again. So it can be a solution for this problem. Idempotent means واحد or something like it in Arabic. The request that must be processed one time only. The server is not allowed to repeat the process of such requests. So if the client repeats to send an idempotent request, the server only processes the first time and ignores the other requests. That's it. Okay, this architecture is a centralized architecture. Why it is centralized architecture? Because all the processes, all the executions, all the services is done on server. That is why we say centralized architecture. Clients make requests from servers and servers provide services for clients. That's it. Very good. Sorry, I was disconnected. And okay. Now we can have different servers. Yes, Mr. Ziauddin, the other issue in this model is that some machines, some computers can be a server and can be a client. For example, machine A can provide services for machine 2 and then can request some services from machine 4. So machine A is server and client. So in some situation, it's difficult to distinguish between clients and servers. It's another issue with this model. I repeat it again. A machine can be a server at this time, okay? So it provides services for other clients. But Sometime later, this machine can play a role of client. It can be a client when it requests some services from others. So it is not easy to distinguish between servers and clients. There are many issues and problems with this model, and also there are many solutions. We don't want to study all these issues and solutions. Many people like to view this style in 3-layer, not 2-layer, client and server, 3-layer. For example, the first layer can be user interface layer, contains units for an application's user interface. I'm sure that you know what is user interface. User interface is something that user uses it to use services, to receive services. It is user interface layer. The other layer is processing layer. Processing layer, as the name implies, is responsible to process, to calculate, to compute something, to provide results. It is processing layer. And data layer, it's very obvious. Data layer is a layer that is responsible to store and to retrieve data. For example, databases. This layering is found in many distributed information systems using traditional database technology and accompanying applications. If I give you an example, you can clearly understand this 3-layered view. It's not difficult, don't worry, it's very easy. Just pay attention to this example. Suppose you want to search something on Google. You want to search a query on Google. What is your user interface? Your user interface here is very, very simple. When you open Google website, you just need to enter your string. For example, your question or your sentence or your word. It's a string of characters. You input a string of characters here. That's it. It's the interface that you use to communicate with Google. It is user interface layer. Then your query, when you submit it, when you press enter, your search query, your string, your characters will be sent to Google servers, and there a processing will be done. Some algorithms for searching, and also we don't know how Google really works, but we can suppose that Google uses some algorithms to find the proper results for your search query. Okay, it is done in processing level. It is done in processing level. When the processing level needs data, the data that you want to see, the data, it can be provided from data level. Data level, some servers that databases are stored on. Then Google uses to read data from servers. It is data level, and then sends the results to you. You can see the results. It is 3-layered view: user interface, processing, and data level. Got it? Yes, of course. Of course. I repeat it again. I repeat it again. I repeat it again. Okay. In three-layered view, layer 1, 2, 3, three-layered view, we have three layers. Okay. The first layer is user interface, UI, user interface level. When you want to search something on Google, you open the website of Google, google.com, okay, that shows a page to you. There is somewhere that you can type your query, your sentence, your words, your characters, okay? For example, you want to give some information about Iraq. So you type Iraq in Google. It is user interface. Very, very simple user interface. You can input just characters here. Then you press enter button to send your request to the Google servers. On Google servers, some processing algorithms are being executed to find the proper results. It is processing level. The way that Google finds the proper results for you, it is processing level. And then when the processing is done, Google uses to show you some data. Data is stored on different server. So processing level can use some servers that are responsible to store data, to read some data, to retrieve some data, and then make a result and sends to you this result. These are three levels: user interface, processing level, and data level. Databases are different from processing level. Processing level is done on different server that is specific for processing. Data level are some servers that database is stored on. That's it. Page titles transform from specific format to HTML format. Maybe I'm not sure about this. I'm not sure about this. Let me give you another example, okay? Let me give you another example. Suppose you want to transfer money between your accounts in online banking, okay? The user interface is the interface that you use to transfer your money. For example, you open the website of your bank, it has an interface, okay, for transferring money. It's user interface. Processing level is some servers of the bank that are responsible to process your transaction, decrease money from one account and add it into another account, okay? It's processing level. And data level is the level or some servers that databases are stored on it. The changes must be made on this database, on servers that are specific for databases. It is data level, that's it. Suppose we have some servers. These servers are responsible for calculating, processing, computing. We have also some servers. These servers are responsible to store databases, and we have a user interface. That's it. Really, it's easy. Clear? Good. Do you want that Mr. Ziauddin translate my speak in Arabic? I'm talking to those students that have difficulty understanding English. Do you want to have a translation from English to Arabic?
Hi doctor, if you want to explain to the student, no issue.
Okay, you can translate. Okay, start.
أساتذة سوى أنطانا هذا المثال على الطبقات مثل ما تقول على اللايرات. عندك يقول لك أكو 3 لايرات اللي هي اليوزر انترفيس ليفل والبروسيسنج ليفل والداتا ليفل. هاي 3 طبقات طبعا احنا دائما دا نستخدمهن بدون ما نعرف اسمائهن. اللي هو هسه اعطاك مثال يقول لك من تفتح الجوجل تريد تبحث عن فد شيء، السيرش هذا اللي تكتب بيه مثلا تبحث مثلا عن فد شيء مفضل إليك على أي شيء تريد تبحث. فهي هاي مثل ما تقول البيج اللي بيها السيرش مع الجوجل هي هاي شنو؟ هي هاي اليوزر انترفيس اللي هي قدامك تكتب بيها السيرش. ورا ما تضغط على الانتر يعني تقول له يابا اريد ابحث عن فلان شيء، تضغط الانتر، وين راح تروح؟ راح تروح الطبقة الثانية للبروسيسنج ليفل. البروسيسنج ليفل شو راح يصير؟ راح يصير معالجة للطلب مالتك. اكو الجوريثم خاصة تحاول تلقى لك افضل ريزولت او افضل نتيجة للكويري مالتك، للاستفسار مالتك اللي انت تريده. اوكي، ولا ما تعرف الاستفسار مثل ما تقول تلقى نتيجة، ولا راح تدزها طبق اللاير الثالثة. شو تسوي؟ تخزن البيانات اللي طلعتها لك، مثل ما تقول تخزن النتائج، افضل النتائج تخزنها. ليش؟ حتى طبعا هاي حتى اللي يبحث عن نفس الموضوع راح يلقاها بعدين، فتصير عملية اسرع. على كل حال ولا ما تنخزن البيانات اللي مثل ما تقول النتائج اللي لقاها البروسيسنج لاير، تنخزن بالداتا لاير، وراها راح ترسل مرة ثانية لمن؟ للبروسيسنج لاير، وبعدها ترجع شو اسمه تظهر لك النتائج. شلون انت تشوف صورة او فد شيء موقع مثلا تكتب فد شيء، هذا راح خلال ثواني يطلع لك. I hope doctor they understood what you wanted to us to understand. Welcome doctor.
Thank you very much. Okay. Students, if you follow this history, it's very easy to understand. User interface, you input your search query here, you send to processing level, the server of Google's query generator can make some processes on your query, and then here from database can some results and data are read, and then the results are ranked here. We have sorting of the results, which results must be shown at first, and then the second, the third, and so on. And then HTML generator makes an HTML page of the results, and the HTML page will send to you. That's it. Real easy. And now I want to talk about more advanced interfaces. I talked about a simple interface that we use in Google. It's a very simple interface that it's only needs some string of characters here. But look at your application. We have Adobe Connect here. It's an application that we use it for video conference, for e-learning. I can teach you by this application, okay? It has a user interface too. For example, there are some menus here. Menu, meetings, layouts, pods, audio, you can see the menu at the top of the application, okay? And you can select some options of this menu. You can mute microphone or enable it. You can mute your speaker here. You can send a box for chatting here, putting comments here, okay? And also, it's a very advanced user interface. It's a very advanced user interface. It's graphical user interface, in fact. Graphical user interface. Very modern user interfaces uses some advanced mechanisms like drag and drop. For example, if I want to share a PDF for you, I just need to drag a file from my desktop and drop it on this application. It will be uploaded here. It's a very modern user interface. Is it clear for you? Okay. If you agree, we can use translator for all the slides. So Mr. Ziauddin or someone else, I don't know, who is fluent in English or Persian, can translate to Arabic. If it's really necessary, we can do it. Okay, I will repeat. Firstly, I asked you a question. If it's very necessary for you, we can use translator to translate to Arabic if you really need. Really? Okay. From the next session, if you have difficulty understanding English, you can request for translation, and then I ask one of the students who completely have understood the lesson to translate that slide for you in Arabic. It's time consuming, but it's okay. If you cannot understand properly, so it is necessary, it's vital to translate. It's very important that you completely understand the lesson. Well, I repeat again the last note about advanced user interfaces. I said that we use a very simple user interface for searching on Google. It's a string of characters. Okay, it's very simple. But we can have advanced user interfaces called graphical user interface. Graphical user interface uses graphics. For example, in this application, Adobe Connect, it is a very good application with advanced user interface. We have some menus. Menu means فهرست, menu. For example, meeting, layouts, pods, audio, and each menu has different options. So we have an advanced user interface here, okay? And also, we can have very modern user interfaces. For example, using drag and drop with mouse. For example, if I want to share a PDF file to you, I can drag the file from my desktop to this software, Adobe Connect, and drop it. And then the file is being uploaded. It is a modern user interface. That's it. Clear? Okay, so I think it's enough for this session. We can continue our discussion next session. Have a good time. If you do not have any problem, any question, we can finish this session. Okay, good night and bye. Khuda Hafiz. We can finish this session with a short dua, with a very short dua. Here, you can see a very short dua here. Can you guess who said this dua? رَبَّنَا أَفْرِغْ عَلَيْنَا صَبْرًا وَتَوَفَّنَا مُسْلِمِينَ. Who said this? Do not search it on Google. Please guess who said this short dua. It's a very good dua, I think. Who said this dua? No. No, Imam Reza, no. It's ayah in Surah A'raf. You will be surprised if I say that that's those wizards in Musa's time. Musa alayhi salam, wizards said this when they saw the fact, they saw the truth. When they saw the truth, yes, saw her. Yes, they said, رَبَّنَا أَفْرِغْ عَلَيْنَا صَبْرًا وَتَوَفَّنَا مُسْلِمِينَ. Think about them. Think about them, about those wizards. I think they were very good people because they can believe in Musa and they can believe in Musa's God, in Allah, and I really adore them. So you can memorize this short dua and say it in your prayer, in your salat, qunut. You can say this. It's a very good dua. Okay, have a good night and Khuda Hafiz.